Okay, you guys, so today we're going to be learning about triangle congruence, and the main thing with it is that you are going to be introduced to these little boxes, these tables. These are called two-column proofs. Okay, you've never seen them before, but it's nothing that we actually haven't done already. You're just seeing it in a different way. So anyway, we're going to do the first three together, and then you're going to do the last three on your own. Here is how you would do it. Okay, so let's start with problem number 1. So problem number 1 says given, which means they gave it to us. They gave us that BC is congruent to EC. Okay, so what I'm going to do is I'm going to take my highlighter and I'm going to highlight those. Okay, these have lines on top, which means it's a line segment. So I'm going to highlight BC and I'm going to highlight EC. Okay, so like I also said, since they are lines, those are sides. So I'm going to write the word side next to it and side next to this one. Okay, they're not angles, or they would have the angle symbol. Okay, alrighty, and then it says what is also given, AC is congruent to DC. So same thing, I'm going to go in with a different color and highlight that as well. AC is congruent to DC. Okay, once again, those are also sides, so I'm going to write the word side to them. Side and side. Okay, and like I said before, the way we know it's a line segment is it has this line on top, and so that's why I highlighted from like A to C and from D to C, etc. Okay, so let's start going over the proof part of it. So this column is your statements. This is like the math stuff, the congruency statements that we have practiced and seen before. This side is the reason. So this is going to be where your vocab words go, okay, or any of the information they gave to us. So the first thing they said is BC is congruent to EC. Well, they gave that to us right over here. Isn't that the exact same thing, just copy and pasted? So my reason, I don't have one. I mean, they gave it to us. So our reason is that it's just given. Okay, because like I said, they gave it to us in the instructions. Okay, so next step, we have to fill in the statement. We can fill in that information because it says that they also gave it to us. It was something else that was given. Well, they gave BC and EC to us, but they also gave this statement to us. So I'm going to copy it down below. AC is congruent to DC. Okay, so that's honestly, these two rows are going to be the easiest part for you to fill out in every single proof because you're just going to copy whatever they gave you and fill it in below. Okay, next comes the stuff where you actually have to think about it a little bit. So they tell us that they are giving us, or our reason is vertical angles. So we have to look at our picture and look at, okay, where do vertical angles exist? Well, if you remember, vertical angles are two lines that cross and they make that X. I notice an X here and there. That's where they cross. So the two angles that are across from each other, let's do this in a blue highlighter, would be these two, there and there. These are vertical angles, and here I'll even fill it in so you can see. Those are our vertical angles, okay? Two angles across from each other. And once again, I'm saying the word angle, so I'm gonna write next to it angle, angle, okay? And there's a reason we're doing that, okay? I'll show you in a second. So those are our vertical angles. Now we have to fill in the statement with those correct letters. If I start with this triangle, these blue, this highlighted angle, let's call it BCA. That would be this angle here. So what I'm going to write is it's an angle, so it gets the angle symbol and the letters BCA. That is congruent to, okay, same thing. Let's look at the other angle now, blue letters DCE, okay? You could go in a specific order. Since I went from the yellow line to the orange line, I should do that again. Let's go from the yellow line to the orange line. So we'll go ECD. But if you use different, or if you go in a different order, that would be fine with me. Like on a test, I would not mark you down for it at all, okay? And then we go, and last thing is, with this information, we can now prove that these triangles ABC and DEC are congruent. And the way we can do that is with this information I wrote down. I don't know if you guys remember from a couple months ago about side, angle, side. It's coming back, right? Side, angle, side. So whatever words you write down, it might be side, side, side. It might be angle, side, angle. But in this case, side, angle, side. So these are congruent by SAS. Okay, you guys, so let's do the second one. I'm gonna go a little bit faster this time. So let's look at what they gave us first of all. FI is congruent to HI and FG is congruent to HG. So those will be the first things I fill out in the columns. Since they already have FG and HD here, that tells me that this first given is that one, right? Because those are the only two things they gave us. So I'm gonna write FI is congruent to HI. Okay, perfect. And FG and HD, that comes from given, so I'm gonna write given. Alrighty. Next comes the properties. So I noticed that we have the reflexive property here. Okay, we have to think back to what the word reflexive property means. That just means that something will always equal itself, right? So AB equals AB, whatever, it always equals itself. So in my picture, I'm gonna look for something where it's gonna be used like twice, essentially, for both triangles. It'll be used for both triangles. And what I notice is I see a triangle here and a triangle here. This line is being shared between the both of them, right? This line segment GI. So that is my reflexive property because this is the thing they are both being used, okay, for both triangles. So what I'm gonna do for the reflexive property, I'm gonna write GI is congruent to GI and it's line segment, so it gets the lines on top, okay? I'm gonna highlight a couple of things because we have all the information we need to know to determine if it's side, 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 angle, side, or angle, side, angle. But let's highlight things so it becomes a little bit more obvious to us. So FI and HI, I'm gonna highlight those in yellow. FI, HI, those are sides. Okay, I'm gonna go to orange. Let's highlight FG, HD. Well, FG's here, HG's here. Once again, those are sides because they got the line on top. And last thing, well, we said that this was the reflexive property because it's always going to equal itself. That is also a side, GI and GI. So this time I got 3 sides. So this is congruent by SSS. And if it helps you, write side by them or write S. That's an S, that's an S, that's an S. These are all S's. Okay, if that helps you, if you don't want to write the whole word, you could write S, you could write A, and you'll be good to go. Okay, you guys, last one, a little bit different, but same concept. Let's go through this real quick. Okay, so let's start with the givens. This information is all that's given. If you look at our table, they have 2 reasons, 2 givens, so I need to put each of them there, okay? It does not matter what order you put the givens, okay? But since this is first, let's just put that first. So JM is congruent to LK and a line on top, okay? And then it says angle JMK is congruent to angle LKM. So same thing, we're just gonna copy it exactly. Okay, the givens are really nice and easy that way. So let's go ahead and do the reflexive property next. So it tells us, okay, something's reflexive in our picture. So I'm gonna look at my picture. It's most likely gonna be a side, guys. What is the side that they both share? Oh, well, triangle JMK and triangle LKM share this side right here, KM. This is our reflexive property because both triangles are using it, right? KM will equal itself. So I'm gonna write KM is congruent to KM, and it's a line, so it gets a line on top, okay? No arrows because there's no arrows there. So, okay, last step. We can now say that JMK and LKM are congruent. They are the same triangle, but we need to know by what theorem? SSS, SAS, or ASA. So let's figure it out. Let's highlight real quick, okay? So let's start with yellow, JM and LK. I'm gonna do those in yellow, J to M, K to L. Okay, those are sides. So I'll put the little S by them. Okay, different color. We got an angle this time. Our angle, we'll do the angle in blue. JMK, LKM. Okay, so if I follow the letters J to M to K, that would be this angle right here. We know it's an angle because it has the angle symbol and it has 3 letters. And then angle LKM, L to K to M, that would be this angle right here. Okay, so since it's an angle, we'll write the letter A next to it so we are aware. And last thing, we notice that they share a side, and that would be side KM. So I'm going to highlight that. And it's a side, so it gets the letter S. Okay, so if we follow the letters, guys, SAS, SAS. This is side, angle, side. Okay, so hopefully that kind of makes sense, guys. I will be back tomorrow to help out more, and we can go over it more slowly. I just want you to be aware when you do the next 3 on the back, there is one theorem called angle side angle, okay? So you could have SSS, SAS, or ASA. And I do have a poster on my wall if you want to look at that, okay? So good luck, see you guys tomorrow, and work hard. This will be graded. Okay, bye.